Okay guys, so last class we looked at how to convert from mole to mass, mass to mole, and also to particles. Today we'll do some problem solving questions that are commonly asked in SPM exams or even IGCSE exams. So I'm taking SPM trial papers first. So if you look at the concept here or the methodology that we are going to use is, first you'll have to convert the given quantity into mole. Second step is use ratio method. Third step, convert mole again to the quantity asked. These are the only three easy steps you're going to use. They want you to calculate the volume of nitrogen gas produced from the decomposition of 19.5 gram of sodium azide. So 19.5 gram is actually the mass. Okay, first step is convert mass into mole. From mass, when you want to go to mole, you have to divide by the RAM or the molecular weight in this case. So it's for the sodium azide is Na3. Always remember, when you're calculating the molecular weight, take the compound by itself. Do not take the number Na3, which is 23 plus 40, 65 gram per mole. Okay. Now this is the molecular weight. Weight given is 19.5. So moles is equals to 19.5 gram divided by 65 gram per mole. You get 0.3 mole. Now next step is the ratio method. Now you see what is given to you, sodium azide, right? So this is given 0.3. Now, what are they asking you to find? This one here, nitrogen, which you do not know. So just put an X here. So how the method works is, it is going to be Na, entry the given one, over what you do not know, equals to, write the number in front, not the mole, the actual moles, the number in front, the ratio. 2 for Na3, and for this is going to be 3, equals to, so for Na3 it's going to be 0.3, here is X, so cross multiply, so you get that as 0.45 mole. Using the ratio method we found the moles of nitrogen. The third step is just going to be converting mole into the quantity asked in the question. We know the mole we are finding for RTP. RTP is 24. 0.45 mole times 24 dm cube per mole. Okay guys, so let's look at this question now. So in this question they say a factory manager has found 5,000 centimeter cube of ammonia gas. So the volume is given to you and has completely reacted with carbon dioxide gas to produce urea and water. Determine the mass. They want you to determine the mass. Now I've given you the equation already because in this part we're only studying how to calculate the, we're only doing stoichiometry calculations. Okay. So now we have the equation, it's balanced already. Okay, so first step, we are going to convert the given quantity. What is the given quantity? Volume of ammonia gas, correct? But the thing is, when you're using RTP, it has to be in dm cube. But here it's in cm cube. So we are going to convert that. First step, we are going to change cm cube into dm cube. How do you do that? Dividing 1,000. 5,000 cm cube divided by 1,000. And you will get 5 dm cube. Okay. Now we have this volume. Next step is going to be, of course, converting volume into moles. We'll look at our chart again. So from volume, we are going to moles. So obviously you have to divide by RTP. Now RTP, you know RTP because they say room condition, and the constant is given as 24, right? So it's going to be 5 dm cube divided by 24 dm cube per mole. Okay, so your answer is going to be, this is basically to find the moles of ammonia. The answer is going to be 0.208 mole. Okay, so second step is ratio method. Now let's see here, what do we know? We know how much of ammonia moles we have, that is 0.208. What we are finding for is urea, we don't know, so we are going to put an X here. Okay, so you know how to do the ratio method, right? NH3 over urea NH2 2CO equals to the number in front, which is going to be 2 over 1 equals to 0.208 over X. We do not know. So cross multiplication, and your final answer for X is going to be 0.104 mole. So our second step is also done. Now let's go to the third step, which is converting it to the quantity asked. They want us to find this is actually the moles of what? Moles of, so we are ready to find the moles of urea. Now next step is we are going to convert that into mass. So moles to mass, again, moles to mass, you must times by RAM. In this case, it's the molecular weight. So let's find the molecular weight of urea first. So the molecular weight of urea. So urea has 2 nitrogen, 14 times 2. Hydrogen, you have 4. Carbon plus oxygen. So the answer is going to be 60 gram per mole. So next one to find, you know, you have to times, right? So it's going to be mass of urea will be 0.104 mole times 60 gram per mole. And the answer is going to be 6.24 gram. Done. Now this question has two parts. The second part asks you to find the number of atoms in carbon dioxide gas. So I have the equation, always write the equation. Now since step 1 we already do earlier, we are going to skip step 1. So you already know that the moles is 0.208, right? But for carbon dioxide we do not know, so I'm going to put an X here. So if we know this is 0.208, but for carbon dioxide we do not know, so I'm just going to put an X. So we'll go to step 2, ratio method. Second part, I'm going to find basically the ratio method. I'm going to use the ratio method to find the moles of carbon dioxide. So it's going to be NH3 over CO2, 2 over 1, 0.208 over X. So again, this number comes here, the number in front of carbon dioxide comes here. Then the actual mole is the next one, and what we are finding for will be X. So solving this, your X is going to be 0.104 mole of carbon dioxide. Okay, now if you see, I have the structure of carbon dioxide here. So you can see here, this is how carbon dioxide looks like. This is the carbon, oxygen and oxygen. It's double bonded. So you can see 2 bonds here. Okay, so now this is one molecule. First, we are going to find how many of these exist. So to find that, From mole, I'm going to go to molecules. So I have to times by the Avogadro constant. So it's going to be 0, number of CO2 molecules. Now that's going to be 0.104 mole times 6.02 times 10 to the power of 23 molecules per mole. So how many molecules do we have? 6.261 times 10 to the power of 22 molecules. Okay, but now this again I'm gonna will refer to the structure here. Now in this one molecule here you can see how many atoms are there. So you see one oxygen atom, one carbon atom and another oxygen atom. Altogether you have 3 atoms here. So in every one molecule you have 3 atoms. So in this many molecules, how many atoms will you have? So you just have to multiply by 3. So it's going to be 3 atoms per molecule times 6.261 times 10 to the power of 22 molecules. So how many atoms do you have? 1.878 times 10 to the power of 23 atoms. Solved.